8.3 miles in another direction. And also, all the directions aren't simply north, south, east, or west. Part A should be easy. Adding scalars, all you do is add up the numbers. Distance traveled is a scalar. You can just add up the numbers. If you had mass, 3 kilograms plus 4 kilograms, all you do is add the numbers together and get 7 kilograms. Same thing with distance traveled here. So you can just add them up. How far has he walked? $30.5 miles. Quite a bit. We didn't ask for his displacement. How far and in which direction is he from his starting point? Where is he in relationship to his starting point? I'm not sure the notation we'll use up on the board is going to be exactly the same as the notation we use in modern physics, but it's basically the same. Right. So the first thing he did was walk 7.2 miles due west. All right, due west, is that in the x direction, the y direction, or some of these? All in the x direction, right? Is it in the positive x or the negative x? Negative. All right. So his first vector, we say negative 7.2 x with a hat on it, which we call x hat. And he did not move at all in the y direction. So we're going to split up each vector into its x and its y components. Negative 7.2 x hat plus 0 y hat would represent the first vector. The next vector, we're going 15 miles at 35 degrees south of west. So start west, go south by 35 degrees. And this side is 15 miles. In order to get the x component, would we use sine or cosine? Cosine to get the x, right? Positive or negative x? Negative x. So for the x component, it's going to be negative 15 cosine 35. It's best just to leave it like that instead of going ahead and typing it in your calculator, because then you're going to have to write. What would the y component be? Negative 15 times sine 35 would give me the y component. The next one, 8.3 miles at 25 degrees north of west. There's west. He's walking north by 25 degrees. And he's going 8.3 miles. Or the x component of that third vector. Good. Going in the x direction, the negative x direction, 8.3 cosine, 25 degrees. What about the y component? Is cosine always going to match up with the x and sine always with the y? No. All right. If this was flipped and it said west of north, those would line up. So it's not a bad idea just to draw a quick picture to figure out what's going on here. All right. Where do we go from there? Add them up. Good. What we're doing is we're separating the x component from the y component. So we're trying to figure out how far east or west he went, how far north or south he went, and then we're going to use those two things to find the result. So we've got negative 7.2 minus 15 cosine 17. Yes, I did. Thank you. Minus 15 cosine 35 minus 8.3 cosine 25. What's that number represent? No, not degrees. The number of miles that he is west of where he started. So 27 miles west of where he started. If we sum the y hat, we can find that he is 5.096 miles south of where he started. And now, just like the last problem, we can use the Pythagorean theorem to get the magnitude of the resultant and the tangent law to get the direction. I'm getting 27.5 miles. For the angle, it's usually best to just draw a quick picture, 27 that way, 5-ish down. Look at this angle right here. It's going to be tangent is opposite over here. 5. Obviously, this is practice. Anything on that? Yeah, they really call them X hat and Y hat. Is that the notation? That's not the notation you used last year. How do you do it? You made it like a hard. Yeah. It's really the same thing. In college, a lot of times instead of X and Y, you'll see I hat, J hat, and then the Z dimension, the third dimension, will be K hat. Same thing, just a kind of a different way, right? If you prefer the chart, by all means, instead of the chart. All right. Last thing we need to talk about today in the middle part. We said we want to talk about the first and the third law of motion. What's the third one say? Yeah, there's one. Doesn't hurt. Yeah, kind of. Interaction forces between two objects occur in pairs, such that the magnitude is the same, but they're opposite directions. Right? So if I push on the wall with the base force of 1 million newtons, the wall will be pushing back on me. That is, you're right. Absolutely. That is it. You're right. Keep it out of the family. So we're trying to take yeah. Forces occur in pairs. And forces occur in pairs. Equal in magnitude, opposite direction. Yeah, the homework should be not there. Yeah. Oh, right. Okay. Last example what we do more about says that a car that has a mass of 1,200 kilograms. It's a mosquito that has a mass of 50 grams. That's a big mosquito. Probably just 6.0. With a force of 3,000 newtons. Mosquito's not going to survive, probably. So if it's a 50-gram mosquito, it's not. Like 5. With what force does the mosquito hit the car? 3,000 newtons, yeah. The same force, opposite direction. Why is this really hard to mosquito? Good, so the difference in the masses are so much that the car's acceleration is not going to change so much. Or the mosquito's acceleration is going to change. Make sense? 3,000 newtons. Everybody needs to come over here and we can help me put the thing on. I think everyone's not up there already. He'll get you one next time. Yeah. Your home instead of with a partner. All right. So number 1, go ahead and try it. You're in your notes or on track paper or something like that, and then you can enter your answer into your quizzes. What is 33 meters vector at a 76-degree angle. Once you've got it, put your answer in the quizzes most or all of those tablets. I think you might have to put enter again. Yeah, I guess it's just one question. Yep. Hey, 100%. Good work. We don't need to talk about it. Number 2.